Earth runs on one simple laundry rule that nobody ever questions. Dirty clothes go into a machine. Clean underwear comes out every single day. Nobody questions that cycle back home. It just happens every single morning without any real thought behind it. The machine handles the hard work quietly. Nobody even watches it run. Mars breaks that rule completely. No washing machine exists, no spare water either. This planet holds no washing machine anywhere on its dusty, wind-scoured surface. Water sits too precious for laundry duty in this hostile environment. Every drop stays rationed for drinking and breathing instead of scrubbing fabric. You would wear the same underwear for weeks on end without complaint. NASA's own guidelines allow up to 30 days for one single pair of pants. Then it gets burned, not washed. Incineration beats washing every single time. Most people picture astronauts as flawless, meticulous professionals in a sterile environment. A sterile lab coat mentality follows them everywhere in the public imagination. Viewers assume some advanced cleaning system must exist already, humming quietly away. Surely engineers solved basic hygiene decades ago, so the thinking goes. The International Space Station tells a very different, far less glamorous story. No laundry machine exists anywhere aboard that station right now. Crew members wear the same underwear for a full week at a stretch. Nobody treats that as unusual aboard the orbiting laboratory. Smell makes the final call, not a calendar. Comfort decides. Pants stretch across 30 full days of continuous unwashed wear up there. Socks and exercise shorts last a full week each before disposal. Every crew member needs roughly 5 liters of water each day for basic survival alone. That water covers drinking first, since dehydration turns dangerous fast in a sealed cabin. Food preparation takes a meaningful share of the remaining daily water supply, too. Basic hygiene tasks like brushing teeth use whatever water happens to be left over. Mission planners cannot simply ship more water from Earth on a whim. 98% must return. Nothing less will do. One missed percent ends the entire mission. Spacecraft must reclaim nearly every drop through tightly engineered recycling loops built for that purpose. Engineers target 98% recovery of all water used on board the station. Anything less turns a Mars trip into a slow countdown toward thirst. NASA actually ordered a laundry machine for the space station back in 2011. 15 years later, engineers are still refining that same stubborn design. Microgravity turns ordinary washing into a genuinely difficult engineering puzzle indeed. Water refuses to fall neatly inside a spinning drum up there. Earth gravity simply does not apply once you leave the ground. No drain works up there. Nothing settles down. Water simply floats freely. Droplets instead float free and cling stubbornly to fabric fibers everywhere they touch. Soap suds drift through the cabin air instead of draining away naturally. A normal earth washer would flood an entire module within a few short minutes. Engineers have tested several prototype designs since that original 2011 order was placed. Washing clothes demands more than a simple drum and some ordinary soap. It requires a machine specifically engineered for true zero-gravity conditions overhead. It also requires a filter capable of reclaiming dirty runoff water afterward. None of that hardware exists yet. Nothing flight-ready, nothing proven reliable. Shipping fresh replacement clothing from Earth solves the problem only briefly for any crew. A 6-month resupply flight can carry extra socks easily enough for now. A Mars crew sits months or years away from any resupply option at all. Engineers instead design garments meant for months of continuous unwashed wear. Current station crews receive fresh clothing shipments roughly 90 days or so. Each item gets worn again and again between those infrequent shipments arriving. Fabric choice matters more than most casual viewers ever realize at first glance. Merino wool resists odor. Cotton simply cannot compete. Every fiber choice becomes a survival decision now. Treated synthetics resist odor far longer than ordinary cotton fibers ever could. Antimicrobial threads slow bacterial growth directly inside the fabric itself over time. Engineers chase every extra day of wearable life through pure material science research. One clever textile innovation can shrink an entire mission's cargo needs significantly. Researchers even study sheep wool chemistry for potential future spacesuit lining ideas. Every gram launched costs thousands of dollars in raw fuel alone. Cargo space stays brutally limited on every single flight headed toward orbit. Engineers weigh everything. Even a toothbrush loses grams. Extra socks lose that fight nearly every time. Clothing competes directly against food, tools, and scientific instruments for that same limited cargo space. A kilogram of spare underwear might mean one fewer scientific sample returned home. A single worn-out sock eventually gets folded into a sealed trash bag carefully. That bag joins a growing pile of retired clothing stored near the airlock. Eventually, the pile fills an entire departing cargo capsule completely, floor to ceiling. Ground controllers command that capsule to undock from the station itself. Gravity pulls it steadily downward toward the thickening atmosphere waiting below. Friction ignites everything instantly. One bright streak of fire. Dirty laundry becomes a shooting star. Passengers on transatlantic flights occasionally spot that fire by pure random chance. Dirty socks and used underwear vanish completely within that same fiery streak. Burning solves two problems fast. It ends a hygiene hazard immediately and completely. It ends solid waste in one motion too, cleanly. Backcountry hikers understand a strangely similar trade-off on every trip they take. Every liter of drinking water gets carried in by hand from the trailhead. Every gram of trash gets carried out, nothing stays behind. Nothing gets wasted on the trail. Nobody packs a fresh shirt for each individual day of hiking on the trail. Hikers instead wear the very same shirt for the entire multi-day trek ahead. They ration their water for drinking rather than for washing dirty socks. Dirty clothes simply travel home inside a sealed plastic bag afterward. Weight and available water dictate every single choice made out on that trail. Some experienced hikers even sleep in the same clothes they hike in daily. A Mars mission stretches that exact backpacking logic across hundreds of millions of kilometers. Roughing it stops being a choice. Daily life, for years. It becomes the baseline condition of daily survival for years on end. Astronauts do not choose this particular lifestyle out of stubborn toughness alone. Physics and basic chemistry force this decision on them directly and permanently. Water weighs too much and clothing burns too easily to waste either resource carelessly. Every single wardrobe choice becomes a quiet negotiation with orbital mechanics itself. Zoom out far enough and the spacecraft becomes a sealed water droplet in the vacuum. Every human aboard breathes and sweats into that same shared droplet for years. Nothing escapes that droplet. Not a molecule. Not without a very good reason. Nothing escapes that tiny floating world without a very good engineering reason behind it. A dirty sock inside that droplet is not just gross to look at. It represents a genuine resource crisis waiting quietly to happen someday. Zoom back in, and that crisis shrinks down to one soldier standing still. He stands there in his own 30-day-old pants, waiting patiently. Sailors faced a strangely similar math centuries ago out on the open ocean too. Fresh water aboard old sailing ships stayed dangerously limited too back then. Laundry got rationed then too, just like food, just like drinking water itself. Sailors wore identical shirts for weeks at a stretch as a direct result. History keeps repeating this same water math wherever resupply runs thin or slow. Mars simply raises the stakes by removing resupply almost entirely from the equation. No passing port exists out there to restock soap or fresh shirts. Future Mars habitats plan to close that entire water loop almost completely someday. Urine gets filtered and reclaimed through several advanced purification stages carefully. Sweat gets pulled directly from cabin air by dehumidifying systems installed overhead. Every drop matters. Every leak counts. Perfection quietly becomes survival itself. Even breath moisture eventually returns to the shared drinking supply on board the craft. Nothing inside a sealed habitat gets treated as truly disposable anymore. Ever. Engineers describe the entire system as a closed loop by careful design. That loop must stay nearly perfect for years without a single failure occurring. That closed loop makes any water spent on laundry feel wildly expensive suddenly. Washing one shirt would quietly siphon precious water away from someone's drinking cup. Every astronaut instinctively treats their own sweat as a valuable resource now. Nothing gets treated as ordinary anymore aboard that station. Discarding becomes cleaning. Nothing complex about it. That is the whole system. Mission designers actually build this expectation directly into the clothing itself from day one. Fabrics get chosen specifically for durability against weeks of continuous sweat and grime. Seams get reinforced so garments survive far longer than any Earth equivalent would. Designers essentially build clothing meant to be worn until it fails completely and totally. Pockets and elastic bands get tested for that same extended lifespan, too, thoroughly. A single failed seam could ruin months of careful mission planning entirely. Quality control checks every stitch before launch day. A worn seam decides its fate, not a laundry cycle. Nothing else matters here. Nothing gets wasted here. Nothing gets washed either. Everything eventually gets burned instead. Future missions may push these same limits even further into deep space itself. A crew traveling toward Jupiter's moons faces years without any resupply at all. Every lesson learned aboard the station gets folded into that harder problem eventually. Engineers already study bacteria growth on worn fabric samples up in orbit. Each data point shapes how long a future garment gets trusted before disposal. The underwear problem becomes real engineering research now, oddly enough. Nobody predicted that outcome decades ago. One tiny discovery, one extra day worn, one less kilogram launched toward Mars. These astronauts represent the absolute pinnacle of modern human engineering achievement today. Years of training and millions of dollars shape every single mission they fly. Life support systems keep their fragile bodies alive inside a total vacuum outside. Their spacesuits alone often cost more than most private homes back on Earth. Every tool around them represents decades of careful, expensive innovation. Yet their laundry routine echoes a medieval peasant's daily habits surprisingly closely still. Water simply outranks clean underwear inside the mission's strict resource budget. Training cannot buy its way around basic chemistry and hard weight limits. Burning wins, losing loses. Cleanliness simply bows to scarcity out here.